Thanks, guys. Yeah, go.
السلام عليكم يعطيكم العافية. سامحونا على التأخير. Tonight we have a great talk and demo prepared for you by Mr. Burhan Khalid. Mr. Burhan Khalid, co-founder of GDG, organizer of GDG, and the e-channels manager of Ahli United Bank, and the best developer in the whole MENA region according to Stack Overflow reputation. And everything else. Without further ado, please welcome Mr. Burhan Khalid.
I'm sure after this talk, my reputation on Stack Overflow is going to go down. Okay, so I'm going to give a talk today about Docker. Before I do, I just want to say that I hate Docker. When I first used it, I did not understand it at all. It was very annoying. I thought the idea was you take an application, you stick it inside a container, and then you can take this container and you can run it on any computer that runs Docker. Back then, it was not the case. When I tried it in production, I even tweeted it. And the people who retweeted my tweet was VMware. VMware. They kept retweeting my tweet. Every time I complained about Docker, they kept retweeting my tweet. Okay. Because we are VMware clients, so they know us. Okay, but a lot has changed since that time, and now I'm at the point where we are migrating all of our production applications to run 100% on Docker. So with that background, what I'll give a short presentation, maybe 10 slides, 11 slides. And then for those that have Docker installed in their laptops, it'll be a good chance for you to follow along, and I'll give you a great demo where it pulls a lot of the Docker concepts. Okay, but just like everything else, we'll just start at the beginning. So this is basically your operating system. This is how it works. The applications talk to a kernel, and kernel handles your hardware, right? And it's very basic. Anyone in computer science class would know this. The reason I mentioned kernel specifically here is because Docker doesn't work on Windows or on a Mac. It works only in Linux. Because one of the core concepts of Docker is Linux containers. For those of you with more gray hair than I have, you might remember partitioning of servers, of mainframes, logical partitioning. PowerPC systems have this a lot. Containers are an offshoot of that. They're not a new technology, they're a very, very old technology. But like most things, they have become commoditized, that's the right word. And now it's what they call the new hotness. That's what the kids say on the internet. So this is your operating system. You have applications, kernel, CPU, memory devices, right? You may have many applications and you may have many user accounts running those applications. If you have a server operating system, you allow concurrent users to run applications, right? And then along comes virtualization. And what they do is they say, okay, we will give you a virtualization layer, which is called a hypervisor, which is this bar right here. Sorry, you cannot see it. And on top of that, we will allow you to run any OS, subject to compatibility. And on top of that, you can run any application. So this is what VMware does. And in effect, what VMware sells you So this is normal virtualization. This is how infrastructure as a service works. Docker is a bit different. What Docker does is they realize that a lot of times you're repeating services that the host already provides. So when you have VMware running on a host, and you are again installing an operating system, which then is talking to the hardware, but the underlying host operating system is already doing that for you. So it's extra things you have to ship. So what Docker does is it takes away the common services that you have into a Docker engine. And so all you ship, or all you, let's say, virtualize, are your application. Is literally your source code. You don't worry about virtualizing your operating system because the operating system is provided. So you don't have to deal with that overhead as well. So all you ship when you ship your container in Docker is your application source and any libraries that are required. That's it. Everything else is already available to you. What that does immediately is it reduces the size of your library. I mean, obviously, you're not shipping the operating system. But more importantly, this is not virtualized. There is no virtualization layer. So this runs at native speed. It runs as if you were running it on the computer installed. With virtualization, there's a virtualization, I don't want to say penalty, but there's a trade-off that your hardware is completely virtualized as well. But here, no. Your hardware is raw or native, and you have direct access to it, as if you would have installed the application on the machine itself. This is one of the biggest advantages of Docker, because it allows you that raw processing power. So you're not handicapped by the virtualization engine. Any questions so far? This is one of the key differentiators between Docker apps, containers, and normal virtualization. And this is part of the reason why it only works on Linux, because the Docker engine relies on Linux containers, the technology built in, and that obviously only works on Linux. When you go to Docker and you download Docker for a Mac, it actually downloads a small Linux distribution that it runs, and inside that, Docker is running. Same for Windows. So you're actually downloading a VMware image. Usually it's a VirtualBox image, and inside it is a Linux distribution, and you run that, and that runs your Docker engine. Okay. So the thing to remember here, Docker virtualizes only your application and services, not the OS layer. So this is one of the key concepts of Docker. So here are some Docker basics, some terms you need to know. A container. So this is actually when you run your application, this thing, when you run it, it's called a container. Okay. It's, you can think of it like a file system directory, except you can run this as code. Okay. An image is a template that you download that's read-only. You download a base image, you log into it, you do your changes to the file system, you commit those changes just like you would on Git, because the file system that's used here has revision control. And then that thing combined runs as a container. So you don't run the image. I mean, you can, but once an image is running, it's called a container. The running system is called a container. A registry is a public directory where images are stored, not containers, images. So when you download Docker, by default, it connects to the Docker public registry to download images. You can have your own private registry. Like for us at the bank, we use a private registry, which has our own images customized for our applications. We don't connect to the public registry. If you download Project Atomic, control how many lessons you issue. Okay, some other concepts. These are some basic commands for Docker. You'll note they all have sudo in front of them. If anyone, sudo just elevates your permissions as a normal user. So by default, if you don't give it a user, it runs it as yours. This is because the Docker command requires root privileges. Docker runs, when you first run the Docker service, it creates a socket, and this socket is owned by root. If you create a group in your Linux machine called Docker, and you add yourself to that group, next time Docker starts, it will change the ownership of the socket to the Docker group, and so you can run the commands without being root. However, I recommend you don't do that, especially when you're starting out, because it's very easy to hold your Docker installation. So this is how you run an image into a container. So Docker run, this is the name of the image. Just give it a name, and if it doesn't exist on your computer, Docker will download it for you. This is the command you want to run. By default, if you just put a command, Docker run Ubuntu, it will run it and you'll put it in the background. Okay? IT means interactive and prompt run the application in the foreground. So in effect, what this does is it downloads Ubuntu, runs bash, and then switches you to that container. So if you type this now, that's what will happen. You'll notice if you don't have images, it'll start downloading it, and when it's done, you'll be inside your Ubuntu container. When you have containers running, you can type this command. It will give you a list of all containers that are running. Docker info gives you info about the Docker image itself. Here's what you can do. So once you download an image and you run it and you're inside a container and you make some changes to the container, you can exit out of that container. The container will be stopped, but it's not deleted from your computer. You can then commit your changes that you did to that container so that next time you don't have to run those commands again. So this is how you do that. Docker commit, give it a comment just like Git, give it an author. This is the container ID, and then you give it a new name. And now, when you run it with your new name, all your previous changes will automatically be there. You don't have to write the name. Okay. Questions? It'll make a lot more sense when we jump into the demo. So why would you use Docker? So these are some of the common use cases. Obviously, it simplifies your configuration because you don't have to worry about it works on my machine, it doesn't work on your machine. Developer productivity. The reason I mentioned that here is because you can easily script Docker. Docker has a very, very generous API. So you can, for example, tell it to build, extract a copy of your source code, configure a machine, build that Docker image, run it. If it's successful, then notify that the build is successful. If it fails, then notify that the build failed. Server consolidation, multi-tenancy. These you would get also if you're virtualizing, but a bit more, you get more density out of Docker because you can run more. Code pipeline management, application isolation. You can run a Docker container completely read-only. So that application cannot write to the file system at all. So it's very good if you're doing one-off, high secure, like you want to run a website and you want to make sure that it can never be compromised. Run a container with a read-only file system, and don't run it on a thick thin client. I'll explain what that means. Enhanced debugging, rapid deployment is one of the biggest ones. There's a lot of, Docker has had huge traction. So there's a lot of things happening around the Docker ecosystem. I'll mention a few. Kubernetes, which is Google's open source management application for Docker containers. It basically allows you to version, but to get the most benefit, you have to get a license. Project Atomic is a free open source Docker optimized Linux distribution sponsored by Red Hat. You can go to projectatomic.org. You can download it. It downloads a special version of Red Hat that has no Red Hat common commands. So you cannot even run yum on it. But it's designed exclusively to run Docker containers. So it's very lightweight. It doesn't take that much of your resources. Okay? But that's not all. There are a ton of things that revolve around Docker. This image is from the Docker Twitter feed at their first conference. And now, if you go, if you Google Docker ecosystem, you'll see a mind map, which links all the different things that work with Docker. I tried to capture an image, but you will not be able to see. I mean, it's that thick. The image is that dense. So let me mention some things. So of course, all the major operating systems are officially supported. These are service providers that either support Docker containers natively or provide container services. For example, Kuwait is a registry. It's a free public registry. It's like Bitbucket. You can have free private repos. You can have free private images stored here. Fig is one that I will use in my demonstration. Fig allows you to identify and configure an application and then it will automatically bring up all the support services that you need. So if your application needs Postgres, you don't need to worry about installing Postgres. Just tell Fig you need Postgres. It knows where to go and download it from Docker. It knows how to configure it, build it. It will set up your your environment variables to the username and password automatically. So in your application, you just pull from the environment variables. It's very simple. Let's see.
How Holoco is related to that?
There's they have tools that use. So this is a quote from most technical workshops that I've been at. So if not enough slideware, so it's time to show you the demo. So I'm going to show you a demo now with hopefully the screen sharing will switch to my demo screen. Okay. Can everyone see this? Yes. Okay. Yeah. Okay. No, sorry. In the 5 minutes that I have in my battery, I'll try to get through all my demo. Okay, so once you have Docker installed, type this command. It'll show you a list of images that you have available on your here. Images downloaded already. If you don't have an image downloaded, you can just Docker pull. For example, you can pull Python, and if you hit enter, let me show you what it does. I will get rid of one that I don't need. So, okay. And what it does is it'll just start fetching Nginx from the public Docker repository. Of course, depending on your internet speed there. So see the version that already exists. Of course, my internet is not working, but it thinks I'm on dial-up. That's how slow it is. But eventually, if your internet is good, it'll download all the layers and start applying them in order. Eventually, you'll have that Nginx image. Now, that image is read-only, so you cannot do anything with it. Once you run the image, it becomes a container. So images are just templates based on which you develop your own containers. Oh, there it is. So let's start downloading. I should have downloaded a small one.
So as a developer, if you have your own container,
yeah.
So you will once you have a release, you will revise your container.
Yes.
So that's
so if you notice,
how your registry will contain the
version.
The version.
Each image is tagged with a version.
Okay.
See, images, you have to understand the difference between images and containers. Container just means something that's running.
Okay.
Right? So when you type this command, this shows you containers. Notice it says container ID. So PS is the process list, right? Whenever you so Docker images, a list of images you have pulled in already. Nothing is running here. It is just stored. You can use these as a starting template to go and develop stuff on. So for example, I have Python. I have an image for Python. I don't know what operating system is installed. All I know is Python is installed. Okay. And you see the tag? So I have Python version 2.7. Or I can just say Python latest. It will pull up whatever the latest image is for. Once I have it downloaded, and this is the size of the image here, Now I can run it, right? So when I run it, now I can start making some changes. So let me run this to give you an idea. What I'll do is I'll run the Ubuntu image. Okay, so Docker run IT. A command to run. If I don't do this, watch what happens. But just run it, just like that. Nothing happened, right? Nothing happened. I'm back to my prompt. But if I go to my PS,
Ubuntu is an operating system.
Yeah,
it's not an application.
Yeah, so you cannot run it. When you run Ubuntu, there's no command for it to run. Right? So just ran it, completely shut down. There's no output.
So it will run full operating system?
No. It will run just the part that's different than what you have. This machine is running Ubuntu here, right? Okay. I can download a Red Hat image and run it here. It'll run just fine. But you notice something? I just ran Ubuntu and the command exited successfully. I did PS, nothing's running. Because the Ubuntu container, when you boot it up, it immediately shuts down because there's no command. Right? PS only shows you running containers. If I do PS-A, it shows me the container that ran rest. It's not running anymore. It exited 55 seconds ago. Right? When a container runs, when an image is running, it's given a unique container ID, the image based on which this container is running, the command that ran. See, when you run bash by itself and you don't prompt for anything, nothing is there for the computer to do. It was created 55 seconds ago. Okay, this container is stopped. I can start it up again and give it a command. So I'll start it up by saying Docker start. Oops. Docker run, right? Sorry. Oh no, it's. Let me check. It's Docker start, but AI to attach. What is it? Run and then attach, right? So I gave it a image name that doesn't exist, an image, not a container name, right? So it's trying to find it. It doesn't find it. So I'm going to give it a container name to run. Now, this is an Ubuntu installation. Okay. I'm going to make some changes. I don't know what's installed. All I'm going to do is I'm going to just update. Okay, just to have a change. Okay. Once I update this and it finishes, now it's running. What I can do is I can open another terminal, and here is my running container. I was running, and you can see this is the name Happy Brathian. Right? It's up 35 seconds and it's running in the background. Okay. I go here, it's still running. Let me cancel it. Now I killed my container. If I go to my PS, it's in all containers, it's there, but it's not in my running container listing. I have made some changes. Now what I can do is I can commit those changes into a new image. Next time I run that image, it will already have the updated app get installed. Okay? So how do you commit? Okay. I have to look at my cheat sheet. So, because This one. Sorry. Yeah, this is the one. AM. Yeah. And oops. Or I can just copy and paste. And so it created a new commit for me.
Which container, like the one that
The one with the-
for 6 seconds.
Yeah. And now it took that container with my changes, it created a new image. It's available here for me in my poster. It's available for me locally. All on Docker containers, all at once, one command. So, what happened? It's done. What it did was, it took my image, it added my requirements, it installed my requirements, it added a user with a disabled password, it ran my requirements, it changed my working directory, and it's done building my container, right? Now, it's going to start. I need Postgres, I need Redis, I need database, so it's my workers are running, my RabbitMQ is done, my database is done, my website is done. And
Celery worker.
yeah, so Celery worker is working. Now if I go to the browser, or actually if I just do this, like you can see the, oops. My servers are not running. So imagine if you can do this and take this act. Oh, I forgot the trick. The trick is, what is, it's for you, this trick. It'll automatically scale up your workers. It'll automatically spool more containers. Yeah. And you know, it's your application, it's live, it doesn't go down. And of course, since Amazon supports Docker, you can run this command right now. So what I did now, Fake is a helper for Docker that allows you to define an application and then all supporting services. And Fake's job is to go bring up all the containers that your application needs, let them talk to each other, automatically. So it takes care of the configuration for you. So my Django application needs Postgres, it needs Celery, and of course it needs Python. So it automatically went and added a Redis, added a web worker for me, added an MQ server, and added a database server. And it mapped the ports. So if I go to my local machine before my computer shuts down, and managed to evolve better.
Fig has been deprecated.
What?
Fig has been deprecated.
Do what?
It's now called Docker Compose.
Yeah, but it's not yet production ready.
They acquired it.
integrated it. So Docker now has auto scaling, and Fig, what Fig does, they call it Compose. So you identify all your services in Docker itself. You bring it.
They keep bringing third-party
They keep
services into
absorbing.
the core.
Yeah.
Has anyone has any questions?
Yes.
I'm using Compose. I'm not using Compose. I'm using Fig. I'm not using any of the auto scaling in production. I'm just using the Docker containers. It's 1.0. We use Red Hat. Red Hat supports it. Red Hat. Special Red Hat type. This is a stripped down version of Red Hat. Just one of the and it's supported free. And they also support Kubernetes, which is Windows document. So you can deploy long posts and manage them. So it's a deployment application on 6 sources. What we're doing in the bank with Docker, switch it off. Turn it off.
Okay, off the record.
Yeah, off the record.
End it permanently, or you're gonna?
I might release it as open source, but I don't have the rights to publish it.
Fine. All right.